Good morning, Math BH. We are going to be working on lesson 7.1D. We're looking at some graphing, and today we're looking at not just functions, but linear functions. So we threw the word in linear with it. So you need to have out your PDF or a piece of paper, or you're doing it electronically, and you're filling it in while we go through the video. Here we go. All right, complete the table of values and sketch the graph of the given function. In the table, round to the nearest tenth when needed. State whether or not the given function is linear and justify the reasoning. Okay, so we're not asking, is it a function? Well, we are, but we're asking more specifically, is it a linear function? So here we should recognize this already as a line. This says no matter what x is, y is 6. So in our table, we have a 6. And we go ahead and we graph it. On our grid, we have to go out to 2 and up to 6. And then no matter what y is, no matter what x is, y is 6. So it is a horizontal line. So I have a question. Is it a linear function? Well, first of all, is it a line? Yes, this is a line. Is it a function? Does it pass the vertical line test? All times that I do a vertical line, I should not be able to hit 2 points. So yes, this is a line and it passes the vertical line test. So yes, it is a linear function. So yes, it is a non-vertical line, because remember, all lines are functions unless they are vertical. All right, next one, we have y equals the absolute value of x. So you might not know the shape of this. So if you don't know the shape of it, then we go ahead and we make our table. If it's an absolute value, that means make your value positive. So if it was -2, it turns to 2. I'm not on my pen. If it's -1, it turns to 1. 0 stays neutral. 1 stays at 1, and then 2. So I'm gridding out my thing. I have to go out 2, up 2, down 2. And I plot my points. And I get -2 goes at 2, 1, -1 to 1, 0, 0, 1, 1, and then 2, 2. So this is a line that got flipped halfway through it, so then it doesn't become a line, because this part was going negative, but now it's going all positive. So then my question, is it a linear function? Well, A, is it a line? No, it's not linear, so it's not a linear function. So I type that in. No, it is not linear. Okay, number 3, we have y equals x squared. So -2 squared. -2 times -2 is 4. -1 times -1 is 1. 0 times 0 is 0. 1 times 1 is 1. And 2 times 2 is 4. So here I have to grid it out. 2 on the left and right, 4 up. And I need to plot my points. At -2, we're at 4. At -1, we're at 1. At 0, we're at 0. At 1, we're at 1. At 2, we're at 4. Now you may think, oh, that's a V shape, but it's not. It's more curved out. You can kind of see it if you plotted more points. It's a U shape, not a V shape. It's a U. Okay, so is it a linear function? Well, is it a line? No. So it is a function, but it's not a linear function. So here, no, it's not a line. Okay, so on your own, I want you to try number 4 and number 5, and then we will go ahead and check it. All right, number 4, we're in the first quadrant, again, because we can't take a principal root of a negative number, and we see that it is forming a curve. So no, it is not a line, therefore it's not a linear function. And number 5, we could be in the other quadrant, but they didn't give us values. So here we're curving up quicker and quicker and quicker. This is exponential. Examine what equations of nonlinear functions, what do you notice? So we have to remember that when it is nonlinear, there's not a first common difference. When a table is not linear, There is not a first common difference. Again, if I'm typing too fast for you, you can always pause the video and catch up. All right, next page. Circle a letter next to the table of data that represents linear functions. So I'm going to do two with you and then let you try. So here, I'm looking at my first difference. On the left side, I see that this is going up by ones, which is all the same. 1, 1, 1, 1, 1. On the right side, this is going up by 5, up by 5, up by 5. That's all the same. So I know that I'd have a slope. I'd have a slope of 5 over 1, or 5. So I know that this is definitely linear. On the next one, here, this is left side is going up by 1, so that's fine. The right side goes up by 4, and then by 8, and then by 16. That is not a first common difference. So that one is not going to work. So I want you to go through the rest of the charts and check which ones are linear and which ones are not. Then play the video. Okay, checking your answers. C, that would be linear. This is going up by 0.2, 0.2, 0.2. This side is also going up by 0.2, 0.2, 0.2. So I know on this one that my slope would be 1. It's linear, not -1. My equal sign didn't go through there. Over here, no. This part is going down by 20, and then it's going up by 140. But this is still consistent going up by 20, up by 20. That's not a first common difference. That's the same. It's not common. E would work. This is going up by 1, up by 1, up by 1. This is going up by 0.1. So when I did my slope, I would get 1 over 0.1, or that's the same as 10 over 1. F doesn't work. This is going up by 2, but this side goes up by 2 and then up by 3. So that's not a first common difference. This one's saying the slope is 2 over 2, and this is saying the slope is 2 over 3. That's not consistent. G doesn't work. Although it's linear, it's a vertical line, so it's not a function. Vertical lines are not functions because each input has more than one output associated with it. And then H works. This is going down by 1, down by 1, down by 1. This is going up by 4, up by 4, up by 4. So I would see that the slope on this one would be -1 over 4. So that is a linear function. All right, number 8. Consider the perimeter of a square as a function of the side length of the square. Complete the graph and the table for this function. Okay, so if I have a square and one of the sides is 1, then I know that the perimeter is 1 plus 1 plus 1 plus 1, which would be 4. Okay, if the sides were each 2, my perimeter would be 8. If the sides were just each 3, my perimeter would be 12. If the sides were each 4, my perimeter would be 4. If the sides were each 5, my perimeter would be 20. We can do a formula. The perimeter is equal to 4 times the side length. So I see, hey, I can write a linear equation for this. So I know that this is going to be a linear function. So I'm plotting my points. At 1, I have 4. At 2, I have 8. At 3, I have 12. At 4, I have 16. At 5, I have 20. I have to decide if this is discrete or continuous. This technically would be continuous because I can have a fraction of a side length and I can have a fraction of a perimeter. You can have 10.5 inches or something like that. So I know that this would be continuous. So I could draw a line if my thing will let me. Take a line right through it. Okay. So write the equation, the model of perimeter as a function of the side length S. So I did that up there. I'll put it down here again. So here we go. P equals 4S. Or if we want to do function notation, remember we have the function P that works on S is equal to 4S. You guys saw a little bit that in an earlier lesson. That would be the function notation way. What does the point 10, 40 mean? So our first value was the side length, and our second value was the perimeter. So it says if the square has a side length of 10, then the perimeter is 40. So we're going to type that one out. if a square has a side length of 10, then the perimeter would be 40 units. Okay, is this function linear? Is this function linear? Yeah, it's a function because it passed the vertical line test, and yes, it is a line. So by the graph, I say yes, it's a non-vertical line. Okay, by the tables, I can see that I have a common first difference. So if I go over here, these are all going up by 1, by 1, by 1, by 1, by 1. These are all going up by 4, by 4, by 4, by 4, by 4. So I can say, hey, it has a slope of 4 over 1. So over here, there is a common first difference. By the equation, yeah, it's in the form y equals mx plus b. Okay, moving on to the next section. Is the relationship proportional? So remember, if something was proportional, it had to be a line through the origin. So yes, this is going through the origin, and it is a line. So it is proportional. So that's a flashback to 7th grade. Yes, it is a line through the origin. First semester, 7th grade, coming right back at you. All right, next page. Consider the area as a function of the side length of the square. So you're going to do the same type of thing, but you're instead of the side, the perimeter, you're going to do the area. So I want you to pause the video, try all of number 9, and then come back and check your answer. All right, check your answers. So here we see that we are not getting a line. It is going up like a side of a parabola. You had to square your number each time. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So we get the area is equal to s squared, or if you write it in function notation, the area, which works on s, is equal to s squared. Would 864 be on there? Yep, 8 squared is 64, so that makes sense. It would say a square with side length of 8 has an area of 64 square units. So from the graph, we told it's not a linear function because it does not make a line. It is a function, but not linear. From the table, the first difference was not the same. The second difference was the same. That's how we know it's quadratic, because the second difference was the same. And in the equation, there was a exponent I put on x, but it's actually on s. Okay, there was an exponent. Linear equations do not have exponents in them. All right, last one. Here we go. A tennis tournament starts with 128 players. Sorry, pause that really quick. Okay, a tennis tournament starts with 120 players. After round 1, there are 64 players left. After round 2, half the players lost and are eliminated to the tournament. Therefore, after round 2, there's 32, and then 16, and so on. Complete the graph and label each axis. So we're going to start out with which round it is, and then we'll know how many players we have. So this, on the bottom, we're going to label as round. And up for here, we're going to have players. Okay, so we started out in round 1. There were 128 players. So right about there. Nope, I don't like that. I went a little too high. Try again. Might be hard with the stylist. Yeah, it's hard with the stylus. Okay, round 2, there was 64. Then round 3 was half of that, which was 32. Round 4, there'd be half of that, which is 16. Round 5, there would be half of that, which is 8. Round 6, there'd be half of that, which is 4. We need to bring my 8 down. My 8 would be under there, which is 4. And then we'd have 2 players. And then we'd be done because we'd only have 1 player and they can't play a game anymore. Okay. Can the round versus numbers of players be modeled as a linear function? So let's look. Can we make a line out of that? I say no. We're not making a line out of that. We are making a curve out of that. So we'd say no, it's not linear. No, it does not form a line. Okay, so this section was really concentrating on the word linear function. First, you have to figure out, is it a line? And then if it's a line, is it a non-vertical line? Because all lines except vertical lines are functions. So you just have to keep looking information. Is it a line? If it's a line, is it non-vertical? If it is a non-vertical line, then it is linear. If it is a curve or something else, it might be a function, but not necessarily a linear function. All right, you should be ready for your homework. I will see you next time. Have a good day.